Hi again, everyone. This brief discussion today is really just about the null hypothesis. So the word the null hypothesis, to me at least, is particularly confusing. It's a phrase that has a definition, but doesn't seem intuitive to deduce just from the words alone. At least it wasn't for me. In this case, it actually means exactly what it says, although it's a little bit of a weird phraseology, right? Terminology is weird. The question is it reasonable to expect some phenomena or thing that we've seen to have just occurred randomly, i.e. that there was nothing unique going on? So null in this case means that nothing was happening that would have caused this. Remember that the idea of a hypothesis test is that we look at a set of evidence and wonder, how likely is this evidence to have occurred or been generated by chance alone? And if it was generated by chance alone, then we sort of would accept the null hypothesis. Nothing was going on. But if it wasn't generated by chance alone, we're going to reject the null hypothesis. It is a default position to test against. That is, we would not expect to see what we saw unless there was some interaction between the features. The null hypothesis provides a starting point for this analysis by assuming that there's no difference or relationship. We can then test the sample data to see if there's enough evidence to indicate something was actually going on. And this is the idea of rejecting H0 because there's some non-random interaction or effect. So it's really our baseline. We labeled this hypothesis, the null hypothesis, as H0, since there's always some chance that two things occurred randomly. And so we're looking for a threshold by which to make a decision that they didn't occur randomly. If it's very unlikely that a relationship between two variables occurred by chance, then there must be something going on, and we set that value of a low p-value of something like 0.05. That is, if the p-value is small, this suggests that the observed data is unlikely to have occurred by chance. And assuming the null hypothesis is true, assuming nothing was going on, it's unlikely that we would have seen this. Therefore, we may have enough evidence to reject the null hypothesis and include that there is a significant difference or there's some relationship between the variables. On the other hand, if the p-value is high, this suggests that the observed data is likely to have occurred by chance. Assuming the null hypothesis is true, therefore, we have enough evidence to reject the null. We do not have enough evidence to reject the null hypothesis, and we conclude that the significance alone, there's no significant difference or relationship between the variables, right? We're saying if the p-value is high, the data is likely to have occurred by chance, and therefore we're going to keep H0, we're going to hold on to it, we're not going to reject it. Now, it's important to note that this p-value does not prove or disprove the null hypothesis, it only provides evidence. The p-value does not indicate the size of the effect or the importance of the result. It's just telling us what's the likelihood of something for us to have seen something by chance alone. So if we're going to reject this null hypothesis, we have to think about this alternative hypothesis. This is the world in which the features are somehow interacting, right? There's some interaction between them. And we often denote this as H1. The alternative hypothesis makes a specific claim about the relationship or differences between the variables. For instance, we might hypothesize that there's a positive correlation between two variables, right? That's often what we're thinking about, is we're asking the question, are two variables related? Are they correlated? And so our H0 is that they are not correlated. Our H1 is that they are correlated. And if we have a very small p-value, then it's an indication that, in fact, they are correlated, H1. But it doesn't give us a probability. It just tells us about some set of evidence that indicates the null hypothesis isn't true. If we reject the null hypothesis, we then must consider whether the alternative hypothesis is a plausible explanation for the observed data. That is, we can't just assume that because we've rejected the null hypothesis, H0, that H1 is true. We still have to use some common sense. And that's something that's often missing, right? So while H0 and H1 are crucial, and hypothesis testing does give us a mathematical method for understanding and interpreting those results, p-value guides the decision-making, but it can't be used just with abandon. And we still have to use some critical thinking, and context are essential in interpreting the results. And we'll talk about errors in p-values, p-value hacking, and other things where that critical thinking and context are crucial for making better decisions.